October 18th, 1943. The clock on the wall reads 4:22 p.m. Outside, the Kaiser shipyard in Richmond, California, is a symphony of industrial fury, the percussive clang of rivet guns, the roar of cranes, the hiss of welding torches, all forging the arsenal of democracy. But inside the Spartan office of Commander Arthur Phillips, the only sound is a heavy, disapproving silence. Phillips, a man whose crisp Navy uniform seems as unyielding as his 23 years of service, stares across his steel desk at the most ridiculous proposition he has ever heard. Facing him is master ship's carpenter Tom Henriksen. At 41, Henriksen is a man shaped by hard work, not by classrooms. His hands, resting on the desk, are calloused and stained, a roadmap of a life spent shaping wood. He has no university degree, no background in advanced physics, but his eyes hold a conviction that is both unsettling and unshakable. Tense, understated music begins. "Let me get this straight, Henriksen," Commander Phillips says, his voice a low growl of incredulity. "You want me to take United States Navy resources and nail fake wooden planks to the hulls of our Liberty ships?" "Not nail them directly, Commander," Tom corrects him, his voice calm and steady, a stark contrast to the storm brewing in Phillips's eyes. "I want to suspend them. Planks that don't actually touch the hull, held off by brackets. We'd be creating cavities of air. It will deflect the German acoustic torpedoes." Phillips leans back, the springs of his chair groaning in protest. He runs a hand over his clean-shaven jaw, looking at Henriksen as if he's a con artist trying to sell him swampland. "Henriksen, the German acoustic torpedoes, the G7ES Zonkenig, were designed by some of the most brilliant engineers in Europe. They are miracles of destructive technology. And you are suggesting we can defeat them with plywood. Plywood from a hardware store." He pauses, letting the absurdity hang in the air. "Are you pulling my leg?" Tom Henriksen doesn't flinch. Before the war, he built houses in Seattle. He wasn't an engineer. He was a craftsman. He knew nothing of advanced acoustic physics or torpedo guidance systems. But he knew something fundamental about how sound behaves. He knew how it travels, how it reflects, how it can be fooled. He knew this because he had spent 15 years building music studios, places where the subtle science of acoustics was everything. What he is proposing in this tense, smoke-filled office will, in the next 8 months, save 27 Liberty ships from the bottom of the Atlantic. It will safeguard nearly 9,000 tons of critical war cargo and preserve the lives of 421 merchant mariners. Music swells slightly, but first, he has to convince the United States Navy that a simple carpenter understands something that their own decorated naval engineers do not. Dramatic pause. If you're with us on this incredible journey, do us a favor and smash that like button. Every click helps our channel share more untold stories of improbable innovation, just like this one. Let's rewind the clock 12 weeks. The summer of 1943. Sound of U-boat sonar pinging in the cold, gray hunting grounds of the North Atlantic. The wolf packs have unleashed a terrifying new weapon. The T-5 acoustic torpedo, nicknamed the Gnat by the Allies, is a technological nightmare. Unlike conventional torpedoes that run a straight course, the T-5 has a primitive but lethally effective acoustic guidance system. Its hydrophones are tuned to a specific frequency range, the cavitation noise generated by a ship's propellers turning at 80 to 120 revolutions per minute. Once launched from a U-boat, the torpedo doesn't just travel, it listens. It locks onto the sound of its target and adjusts its course automatically, relentlessly homing in on the acoustic signature. It doesn't matter how frantically a ship's captain zigzags or executes emergency maneuvers. The Gnat follows the sound all the way to impact. Sound of a massive underwater explosion, followed by the groaning of stressed metal. Its effectiveness is devastating. Between July and September of 1943, German acoustic torpedoes sink 41 Allied vessels in the North Atlantic. Liberty ships groaning under the weight of tanks and ammunition, nimble destroyer escorts, lumbering freighters. The T-5 does not discriminate. If you make noise in the water, The torpedo finds you. Music becomes somber. Back in Richmond, California, Tom Henriksen is a man living with the ghosts of these attacks. He supervises repair crews at the Kaiser shipyard, patching up the Liberty ships that managed to limp back from the Atlantic convoys. For 8 brutal weeks, he walks through the dry docks, staring at the ghastly, twisted holes punched in their steel hulls by German torpedoes. He talks to the survivors, men with thousand-yard stares who have seen hell and returned. He hears the same stories, over and over again. The torpedo followed us, one young sailor told him, his voice trembling. We made 2 hard turns full rudder. But it was like it knew exactly where we were going. It just turned with us. On September 23rd, Henriksen is overseeing minor repairs on the SS Benjamin Harrison, a Liberty ship that, by some miracle, survived a U-boat attack. He's inspecting the hull near the stern, running his hand over the cold steel plates. His fingers trace the weld seams, the lines of rivets, when he notices something odd. A section of steel plating, about 20 feet long, has been partially peeled away from the ship's internal frame by the shockwave of a nearby explosion. It has created an air gap, no more than 3 or 4 inches wide, between the outer plate and the inner structure. Music shifts to a curious, investigative tone. Curiosity piqued, Henriksen takes the ball-peen hammer from his belt. He taps the loose, delaminate plate. Sound of a dull, muffled thud. It produces a hollow, muted sound, the energy absorbed by the gap behind it. Then, he moves a few feet over and taps a normal section of the hull, where the steel is flush against the frame. Sound of a sharp, bright clang. The sound is completely different, a bright, metallic ring that reverberates through the structure. Thud clang. He taps them again. Thud clang. Dramatic musical sting. In that moment, something clicks deep in his mind. A memory surfaces from his life before the war, a life of sawdust and blueprints. He had built dozens of music studios for radio stations and recording artists in the Pacific Northwest. He knew that if you wanted to soundproof a room, to stop sound from getting in or out, you didn't just build one thick, solid wall. That was inefficient. Instead, you built 2 thinner walls with a pocket of air trapped between them. You built floating walls that didn't directly touch the main structure of the building. The sound waves would hit the first surface, travel through the air, hit the second surface, and bounce back and forth between them. With each reflection, the sound would get distorted, lose energy, and die. What if you could apply the same exact principle to a 400-foot-long ship? The German acoustic torpedo was designed to home in on the direct sound of the propellers, a sound that traveled through the water and reflected cleanly off a solid steel hull. But what if the hull wasn't acoustically solid? What if there were strategically placed air cavities that would warp and distort the way the sound reflected? The torpedo's primitive brain might hear an altered acoustic signature. It could be tricked into tracking a false echo instead of the real ship. Music builds with a sense of discovery. It might miscalculate the target's position by just enough to miss. For the next 3 weeks, Henriksen becomes a man possessed. He works his long shifts at the shipyard, then goes home and develops his idea in secret, sketching diagrams on notebook paper at his kitchen table late into the night. He tells no one, not even his wife. He knows how utterly absurd it sounds. He uses the basic trigonometry he learned for building roof trusses to calculate acoustic reflection angles. The challenge is immense. He needs to create resonant cavities on the hull that will distort the ship's acoustic signature without compromising its structural integrity or slowing it down in the water. Then he remembers the supply depot. The shipyard has thousands of square feet of 3/4-inch marine-grade plywood, stockpiled for deck repairs. His plan solidifies. He will install phantom planks on specific sections of the hull. These wooden planks wouldn't be part of the ship's structure. They would be suspended 4 inches away from the actual hull, held in place by simple, L-shaped steel brackets. This would create a precise air gap between the wood and the steel, a perfect acoustic trap. On October 14th, in a forgotten corner of the machine shop, Henriksen builds a 1/10 scale model. He uses a sheet of steel, a few scraps of plywood, and a large water tub. Sound of a tuning fork ringing, he strikes a tuning fork and holds it underwater, generating sound waves. First, he measures how the waves reflect off the bare steel. The reflection is crisp, clean, predictable. Then, he attaches his suspended plywood planks, creating the air cavities, and tries again. Music swells to a triumphant crescendo. The results are astounding. The acoustic reflection from the modified hull is scattered, distorted, and messy. Using a simple protractor and a bit of string, he measures the difference. The apparent point of reflection, the spot the sound seems to be coming from, is displaced by nearly 18 degrees from the actual point of reflection. 18 degrees. At the engagement ranges of a torpedo, that was enough to make it miscalculate a ship's position by several hundred feet. Henriksen knows his washtub model is ridiculously simplistic compared to a real ship in the churning ocean. But it's proof. It's enough to suggest the idea just might work. And so we return to October 18th for 22 p.m. in the office of Commander Phillips. The air is thick with skepticism. Henriksen, this is physics. It's impossible, Phillips scoffs, shaking his head. The Germans designed these torpedoes to track complex acoustic signatures in a noisy ocean environment. Music, and you think you can fool their multi-million Reichsmark weapon system with wood? Tom meets his gaze, his voice unwavering. Commander, with all due respect, we have lost 41 ships to those torpedoes in 12 weeks. Whatever countermeasures we're using right now are not working. My modification would create resonant cavities that distort the hull's acoustic reflection. Music becomes more serious, and pleading, my scale model shows an angular displacement of 18 degrees. If that translates to full scale, a T5 torpedo would miscalculate our position by hundreds of feet. Maybe that's enough for a miss. Philip stares at him for a long, silent moment, the gears turning behind his eyes. He is a man of regulations and engineering specifications, but he is also a man desperate for a solution. If this works, Henriksen, it's brilliant. If it doesn't, you've just built stupid-looking wooden fins on a warship and wasted precious time and materials. He leans forward, his eyes boring into the carpenter's. Do you understand that if this fails, your credibility, your career here is finished? I understand, sir, Tom says, without a flicker of doubt. Phillips nods slowly, a decision made. You have 1 week, 1 ship, and this will be a controlled test only. Don't disappoint me. For the next 6 days, Henriksen and a hand-picked team of 8 trusted carpenters work with a feverish intensity. Their test subject is the SS William Clark, a brand-new Liberty ship scheduled to join an Atlantic convoy in 3 weeks. The installation is more complex than Tom's simple drawing suggested. The 3/4-inch marine plywood planks are cut into 12-foot-long, 18-inch wide sections. They are painstakingly suspended 4 inches off the hull using stainless steel L brackets, welded to the hull every 2 feet. They don't cover the whole ship. That would create too much drag and affect its speed. Instead, Tom directs them to install the planks only on the most critical zones, the areas of the hull directly adjacent to the propellers, where the ship's acoustic signature is the loudest and clearest, the very sound the T5 was designed to hunt. Sound of hammers, saws, and welding. When they're finished, the result looks utterly ridiculous. The sleek, utilitarian lines of the warship are now marred by what looks like wooden shelves or decorative fins bolted to its sides. The professional sailors and engineers who see it shake their heads and snicker. They start calling them Tom's Folly. On October 25th, the William Clark steams out under the Golden Gate Bridge for sea trials in the open waters of San Francisco Bay. A Navy vessel pulls alongside, carrying a team of acoustic engineers with sophisticated hydrophone equipment. The engineers expect the modification to make no difference at all, or worse, to actually make the acoustic profile louder by adding new reflective surfaces. Tense, scientific-sounding music begins. What they discover leaves them speechless. The air cavities between the plywood and the steel hull are creating a complex field of acoustic interference. The sound waves from the propellers are bouncing back and forth between the multiple surfaces, losing energy, smearing the signal, and creating phantom echoes. The ship's apparent reflection point is shifted by a staggering 14 to 22 degrees, depending on the listening angle. Most importantly, the ship's overall acoustic signature is significantly fuzzier, in the precise frequency range that the German T-5 torpedoes used for tracking. A senior naval engineer from the Bureau of Ships pores over the data printouts for 2 hours, his brow furrowed in concentration. Finally, he looks up at Henriksen, a look of grudging respect in his eyes. "Theoretically," he says slowly, "this shouldn't work this well. But the data doesn't lie. This modification is distorting your ship's acoustic signature. Exactly the way you predicted." But there is a world of difference between fooling Allied detection equipment in the calm waters of the Pacific and fooling a German torpedo in the heat of combat. There is only one way to know if it truly works. It has to be tested against the enemy. On November 3, 1943, the SS William Clark, with its strange wooden fins hidden beneath the waterline, sails to join convoy HX 264, bound for England. It is one of 53 merchant ships, escorted by a thin screen of 7 destroyers, plunging into the U-boat-infested waters of the North Atlantic. What happens 2 weeks later, in the dead of night, will change everything. Music shifts to a thrilling, dangerous tone. November 17th, 2:34 a.m. The position is 490 miles southwest of Iceland. The sea is black, the air is cold enough to burn the lungs. Below the waves, the German submarine U-382 has detected the convoy. Its commander, Captain Lieutenant Friedrich Wilhelm Marienfeld, expertly maneuvers his boat into an attack position. Through his periscope, he sees the dark shapes of the merchant ships, fat, slow-moving targets. He gives the order, "Rohr 1 und 2 Feuer." Sound of torpedoes being launched, with a hiss of compressed air. 2 T-5 Nat torpedoes leap from their tubes and begin their hunt. The first torpedo acquires a target, the SS Thomas Jefferson, a standard Liberty ship with no modifications. Its acoustic sensors lock onto the steady thrum of the Jefferson's propellers. The torpedo follows the sound perfectly. At 2:41 a.m., it strikes the ship midships. Sound of a massive explosion, alarms blaring. The Thomas Jefferson is mortally wounded. It sinks in 11 minutes, taking 34 of its crew down into the freezing darkness. The second torpedo tracks the SS William Clark, the ship with Henriksen's bizarre wooden fins. It closes from a range of 800 yards. Its acoustic system detects the propeller noise and calculates the target's position based on the reflection of that sound off the hull. But the reflection it receives is not clean. It's warped, distorted by the air cavities of the phantom planks. The torpedo's simple guidance system is fooled. It calculates that the William Clark is approximately 180 feet further north than it actually is. It adjusts its course, arrowing toward the ghost position. At 2:43 a.m., the crew on the bridge of the William Clark hear a terrifying roar as the torpedo, its engine screaming at full power, passes just 190 feet off their port bow. Sound of a torpedo speeding past at close range. A complete miss. The ship's captain, Harold Stevens, radios that a torpedo has missed them. He has no idea why. He just thinks he's the luckiest man on the Atlantic. But when the ship arrives safely in Liverpool on November 24th, British naval engineers examine the hull as part of a standard inspection. They find faint scouring marks on the ship's bottom paint. The acoustic pings from the torpedo's guidance system had definitely tracked the William Clark. It had been a perfect lock. It just miscalculated the final position. Uptempo. Hopeful music begins. The British flashed the report to the U.S. Navy on November 28th. On December 2nd, the document lands on the desk of Commander Phillips back in Richmond. He reads it once, then twice. A slow smile spreads across his face. It worked. Henriksen's absurd, impossible hardware store modification actually worked. On December 8th, the U.S. Navy issues an immediate, top-priority directive: implement the modification on all Liberty ships departing from West Coast shipyards. By January 15, 1944, 89 Liberty ships have the system installed. By March 247, the system is officially designated the Passive Acoustic Distortion System Q-25 Henriksen, but the merchant mariners who owe their lives to it have a simpler name. They call them Tom's fins. The results during the first 8 months of 1944 tell the whole story. Of the unmodified Liberty ships attacked by T-5 torpedoes, the impact rate was a terrifying 73%. For the Liberty ships equipped with Tom's fins, that rate plummeted to just 39%. The modification reduced the torpedo's effectiveness by nearly half. It didn't make the ships immune, but it gave them a fighting chance. It's estimated that 27 Liberty ships, carrying over 8,100 tons of military equipment and 421 merchant mariners, survived direct T-5 torpedo attacks specifically because of Henriksen's invention. The German Kriegsmarine knows something is wrong. Music becomes more thoughtful in January of 1944. The commander of the U-boat fleet, Karl Donitz, writes in his war diary, "The impact rate of the T-5 torpedo against American targets has fallen inexplicably. A possible Allied acoustic countermeasure has been implemented." The Germans eventually develop improved acoustic guidance systems, but the war ends before they can be deployed in significant numbers. Thomas Henriksen receives the Navy and Marine Corps Medal on March 14, 1944, for exceptional technical innovation in anti-submarine countermeasures. After the war, he doesn't take a high-paying job as a Navy consultant. He doesn't become a famous naval engineer. He goes back to Seattle and builds houses, exactly what he was doing before the war began. But for 2 crucial years, his absurd wooden fins saved hundreds of lives. There's a profound irony here. The Germans developed the T-5 acoustic torpedo using some of the best physicists, acoustic engineers, and technicians in Europe. It was cutting-edge technology, representing years of advanced scientific research. Tom Henriksen defeated it with plywood and a working knowledge of how to build a music studio. Why did it work? Because the German engineers designed the T-5 to hunt for acoustic signatures in a natural ocean. They made a critical assumption that ship hulls were solid surfaces that would reflect sound in a predictable way. They never anticipated that someone would intentionally modify a hull to create acoustic distortion. Henriksen didn't understand the advanced theory behind wave propagation in fluid mediums. But he understood, empirically, how air gaps change the way sound behaves. He had seen it work in dozens of studios. He applied practical knowledge from a completely unrelated field to a military problem, and it worked because no one else was thinking that way. The advantage of not being an expert is that you don't know what's supposed to be impossible. Tom Henriksen didn't know you couldn't defeat advanced torpedo technology with plywood.
So, he tried it anyway.
And because he tried, 421 merchant mariners got to go home to their families instead of drowning in the icy waters of the North Atlantic. Sometimes, the best technology isn't the most advanced. It's the one that works. Final, reflective music begins. What do you think of this extraordinary story? Did you know how a carpenter with no scientific education defeated one of World War II's most advanced torpedoes using plywood? Do you believe the best military innovations come from experts in labs, or from practical people looking at problems from a completely different angle? Let us know your thoughts in the comments below, and be sure to subscribe to our channel. Every week, we bring you verified, fascinating stories of improbable innovation that changed the course of history. Hit that notification bell so you never miss an episode. Drop a comment right now, let us know where you're watching from, and tell us what other incredible stories from World